and welcome back. We are in my kitchen because the conservatory is too hot again, but that's okay. We can do our science anywhere really because we're still focusing on water, so it's not too messy. Today we are going to be focusing on the different particles of a liquid form. That sounds very complicated, but it's really not. And we got a really cool experiment, and all we need is a little cup of water, half full, third full, don't have to be that accurate. Some cooking oil. Please ask your parents or carers. We don't want to be using the last dregs of the cooking oil for a science experiment. That will not go down well. So triple check. And we're going to add some food colouring to the water. And what that's going to do is it's just going to make it that little bit more visible to see. And the reason we are doing this experiment is because we're going to be learning about the density of liquid. So I'll give you the theory first and then we'll show you the practical. Now in this water, it just looks like a clear liquid. It's very boring, we drink it, thank goodness. Actually our bodies are really full of water. I mean, you can't live without it. But water's magical because inside water, although you can't see it, there are gazillions, I'm sure that's not the scientific term, of little tiny particles, and those particles sit quite close together so that they're sort of huddled a little bit. They're not sat as so tightly together as a solid material, but we'll get to that another day, but they sit quite tightly together. Then we've got another liquid here, which you can see is still liquid, still flops around in a bottle, just like the water would do, but it's a slightly denser material. So the particles in here are still quite loosely sort of packed in, but they're fatter, okay? So that makes the difference. So we're going to show you the experiment and then we're going to explain what happened. Okay, so I've got my very willing volunteer. Please put on your safety goggles, my darling. Okay. I'm not going to show you her lovely face because she's not ready for fame yet. Just our assistant has. Now what I'd like you to do, we've got a bit of food colouring. You need the tiniest drop, and I mean the tiniest drop, into the water. Okay? Tiniest drop. No, you don't need to use a spoon. Just put a blob, little drop, and watch it go through. Here we go, blob, that'll do. Now what we do is we look at that. Now, you can stir it, please. Thank you. And what that's done is that's turned the water into a funny colour so we can see it a bit better. Yes? Now, we're going to take out the spoon. And I will do this bit now. I want you to look very carefully at the water. Now I'm going to pour some oil. Now look what's going to happen. Now look what's happened there. So it poured in the same as a liquid, but where's the oil sat, Poppet? At the top. Have you any idea why? Give it a little stir, see what happens, just a gentle stir. Right, so we've mixed it up. Now take your spoon out again. So hang on a minute, we did that with the food colouring.
Well, it's stuck at the top, but it's in the water.
That's it, it's in the water, but it's at the top. And there's a very good explanation for this. So the food colouring that we put in the water has the same particle density. It's got all its particles closely crammed together. You know, like penguins in the Antarctic when there's a snowstorm, they all properly huddle together just to keep themselves protected. Yeah? So that's what these water particles are doing. So they can mix because the food colouring and the water have the same particle density. But the oil that is sitting on the top has a much fatter particle density. So instead of it having lots of little penguins, it's got one big sea lion. So a sea lion couldn't fit in amongst a load of little penguins, could it? It would sit on top. And that is basically liquid density. Okay, so let's take this one step further and let's add more food colouring and see what happens. So stick another blob in. Thank you. Now give that a stir and let's see if the oil can absorb any of the food colouring. Let's have a look. Now let it settle. Now look at that. Can you see that the water has gone a darker colour and yet the oil hasn't changed colour? Why not?
Because it has the same identity.
Well, almost. The oil can't take in those particles, can it?
No,
And yet the water can.
And I've also realised all those bubbles were just floating around, but now it's stuck to the oil.
Yeah, well, what the air has got in where we've stirred it, the oil, the air pops, and then, yeah, the oil settles again. If you were to leave it now, and if we leave it for 5 minutes and we'll take a photograph, that oil will be a nice layer of oil. That's why it's so bad if there's an oil spillage in the sea. Because it basically puts a film across the ocean, which is terrible, isn't it? So there we go. And this is exactly what we were talking about. So liquids aren't firm, they flow and they can be poured easily. They aren't easy to hold, and if you try lifting water, it will trickle between your fingers. Liquids change their shape depending on the shape of the container that they're put in. Like solids and gases, liquids are made up of tiny invisible particles, and in liquids the particles sit slightly apart from each other and they move a little. Oh, so not quite like the well, no, do they move a little bit? They're not stuck together, are they, I suppose? In liquids like water, the particles sit slightly apart from each other and they can move around, and that's why liquids flow and can be poured. And we can see here we've got something being poured nicely, and then obviously it goes into the shape because it can do that. And here we've got the particles, and actually with our oil those particles are just much fatter, which is why they sit on the top, because they can't possibly go in those little gaps because they're too sort of squashed in, and the oil particles are just too plump. So have a little go. See if you can do your own water and oil experiment. Also, you can try a little bit of washing up liquid, particularly once you've put the oil in. That's quite interesting. I'll leave that one for you to find out, just a blob at a time. I hope you're all doing well. I miss you. Keep up the good work. See you soon.